Hello everybody, this is Karma Killed the Cat, and welcome to your 14th Lua tutorial. In this tutorial, we'll be going over the last two methods in our metatables that we didn't go over in the first metatables tutorial. So what those methods are finalizers and weak values. So we're going to start with weak values. So in Lua, there is something called a garbage collector that every once in a while goes through and takes all the memory that has been used by the Lua program but is no longer being used, so there's no more references to it. So say we have or let's just say x equals 1 and y equals x. So saying x equals 1, that's creating a variable called x and sending it to the value 1. And if you're familiar with pointers in C++, this is all kind of like that. So x is just pointing to a value in memory that says 1, and y is also pointing to the same place that x does, because it equals x. So now if we say x equals nil, we're deleting that reference from our value 1. And if we say y equals nil, we're deleting the reference to 1 that's called y, so now there are no more references to this value 1. So now at some point in this program, before it ends, the garbage collector will see that the value 1 no longer has any references to it, and it will delete that. So in most cases, this is enough for memory management in Lua. You usually don't have to worry about it. But every once in a while, you'll, especially with tables, and that's what we're going to go over, you will have to manually manage your memory. So let's create an example to show weak tables. So what we're going to do is we're going to create a table called sprites and set it to empty table. And this example is just going to be a table full of tables that store information about sprites. And we're not actually going to create sprites and display them on the screen. This is just an example. We'll get to graphics programming in a different tutorial series. So now that we have the table, we're going to say set metatable. Set metatable, and we're going to put sprites as the first parameter, and in the second parameter we're going to have an anonymous table, and in that we're just going to say underscore underscore mode equals, and just have a string that says v. So what we're doing here is we're setting the metatable of sprites to this anonymous table that just contains one meta method, and that's mode. And since the entire metatable is only one string, it's not a bunch of functions and tables, we're just using an anonymous table instead of actually creating a separate table for this. So now let's add some values to the table. So we'll say sprites at position 1 equals, we'll say sprite 1, and then we'll just have some random numbers for the x and y values. And we can copy and paste this, we'll say 3 times. So position 2 and position 3. Change this to 2 and 3. And make these have different numbers in them. Doesn't actually matter what numbers are in them. So we just have some random numbers and strings in there. So now we're going to set two variables. We're going to say player equals sprites at position 1 and enemy equals sprites at position 2. So what we're doing here is we're creating another reference to these tables in our sprites table. And the reason we're doing that will make sense in a minute. So now we're going to call a new function. It's called collect garbage, I think. That's the function, right? Yep, that's the function. And this just forces a garbage collection. So it forces Lua to go through all the values in the stack, which is just a table full of all the variables that you're using in your program, and make sure they all have references to them, and if they don't have references to them, it deletes them. So now we're going to output all the values in our table. So we'll say for kv in pairs sprites do print k comma v and end. So now let's save this. And before we run it, let's talk about what we think should happen. So logically, we think that printing all the values in our sprites table would print the sprites at position 1, so it would say 1 equals, and then the identification number for the table, 2, identification number for this table, 3, and then the identification for this table. So that's what should happen, but let's run it and see what actually happens. So open, and we just see 1, and then the table's ID, 2, and then the table's ID. So you're probably wondering why that third value in our sprites table didn't get displayed. And you also may have noticed that the two values that we set references to, the player and enemy, those two values were displayed, and the last one that didn't get another reference was not displayed. So the reason for that is because we gave this table weak values. And what weak values means is that the reference that the table gives to an object is not enough to keep that object in the program. So you can call this table here, you can access it by using sprites at position 1, but the garbage collector doesn't see this reference as enough to keep it in the program. So if this sprites at position 1 is the only thing that only reference to this table, then the garbage collector will still take it. But we see here for sprites at position 1 and 2, we have separate references, the player and enemy references. So the garbage collector sees those and doesn't take those two values out. But sprites at position 3 doesn't have any other references, and so since this table has weak values, the garbage collector doesn't see this one reference as enough, and it throws this table here out. So hopefully you can see how weak values can be useful. But now let's get on to weak keys, which are slightly different. So we're going to delete our old example, and we're just going to create a smaller example for this. So create an empty table. You can call it whatever you want. I'm just going to call it X. And then we'll call set metatable again. And we'll set the metatable of X to another anonymous table. And in that, we'll just say mode equals, and then instead of putting V in the string, put K in the string. Because now we're talking about weak keys, not weak values. So now we're going to create another empty table called key. And we're going to say X at position key equals 1. And then we'll print X at position key. Then collect garbage. I'll explain what we're doing here in a second. Collect garbage. And then say key equals empty table again, and X at position key equals 2. So this probably looks a little weird to you, and that's understandable. The main thing that probably looks weird is that we're indexing a table with another table, but that is legal. Since each table has its own unique identification number, you can index a table with a table. It will work. But the other thing that may seem weird is that we're just creating this. Oh, 1 second, my dogs are barking. Alright, sorry about that. So, as I was saying, another thing that may seem weird to you about this is that we're creating this key, setting a X at position key to a value, and then I forgot to delete key equals nil. Then we're just deleting it, and then setting it to something else. And then I should also X at position key. And we can also print it again here. So basically what weak keys are is it's the same as weak values, but it's saying is that the keys of the table must have separate references to them for them not to be deleted, rather than the values of the table having to have separate references to them for them not to be deleted. So you can see that we've created our key, and then we've used that key to index a value 1, and then we delete the key, and then we collect garbage, so the garbage collector sees that the only reference to this key table is the fact that it's being used as a key for the value 1 in our X table. And since X has weak keys, the garbage collector removes it. So that's how you use weak keys. They're not quite as useful as weak values, but I can see them being used in some situations. I've never used them. I've used weak values, but I've never used weak keys. But I can see that they can be used in some places. So just one more thing about weak keys and values before we get on to our next method. So I said earlier that the garbage collector looks for objects in tables with weak keys or values. It looks for objects that only have that one reference to them and then deletes those. By object, I mean either a table or a function. Numbers, strings, and booleans don't count as objects. They're variables. But any table or function with weak keys or values will get deleted. So now let's go over the second method we're going to go over in this tutorial, and it is called Finalizers. So if you're familiar with C++ or C#, then this is just a constructor. It's the exact same thing. So for the example, we're just going to create an empty table, and we're going to set the metatable. Set metatable X, and then another anonymous table, and then say underscore underscore GC. I'm not sure why it's called GC. It probably means something, I just don't know what it is. So underscore underscore GC equals, and then create an anonymous function. Whoa. I didn't know that happened. I guess that's cool. It's something that Sublime Text 2 does. And we can delete these periods. So now in this function, you can put anything you want, but I'm just going to say print deleting table X. So if you don't know what destructors do in C++ or C#, probably also in Java or any other object-oriented programming language, this probably applies to. It's basically just a function that's called when the class or table is getting deleted. So now let's actually delete the table. So we'll say x equals nil, and then force a garbage collection. So now we can save, and I would forget to not close the folder, so sorry about this. So now if we run this, nothing happens. One sec. Okay, so apparently finalizers only work in Lua 5.2, and as I've said before, I'm still stuck on Lua 5.1. So sorry about that. I'm still trying to get Lua 5.2, and once I do, I think there's like 2 tutorials now that I'll need to do. But just know that this is how it works, so if you do get Lua 5.2, if you find a way to do it for Windows, then you can use these, the finalizers. But if you're using Lua 5.1 like me, these don't exist, so sorry. But that's about all for this tutorial, and until I get Lua 5.2, this is the last of the main tutorials. After this, we'll be getting into the libraries, like the IO library and string library. The math library will be first, so see you in the next tutorial.